Square roots are the opposite of squares. Okay, so when we've been doing x squared, it does have an inverse operation, which is the square root. So we're going to be talking about those inverse operations just for a second here so you understand what the radical is. Okay, again, it could be called a root or a radical. You've called it a square root for your whole life, and I'll show you why later. Now, if I asked you, what is the square root of 1, what would you say? 1. Because
1 times 1 equals
1 squared, or 1 times 1, is equal to 1. So since this is squared, the square root undoes it. It's its inverse operation. Okay, we should have probably our first 12, if not 13, squares memorized because it's in the 12 by 12 times table. If you don't have them memorized, that's fine. I will show you how to get around this, but you should have them memorized. What is the square root of 100? Don't say 50.
10.
You're about to say 50. Because it is 10 because 10 squared is 100. So the square root of 100 is 10. You see how these are opposites? Squares get bigger, square roots get smaller. What's the square root of 49?
7.
7, because
7 squared equals 49.
7 squared is 49. Now here's the deal. If you honestly do not know how to do this in your head because you don't have your times tables memorized, your calculator can help you out. So everyone check out their calculator for a second. There is a square root button. Can anybody find the square root button?
First of all, you gotta.
It's below the x1.
Yes, I hear the general murmur saying, if you notice, let's see if I can show you, above the x squared button right here, you really cannot see it on my screen. You see that blue square root?
I seen it.
That's what we want. Now, since it's blue, what button do you have to push before you push that button? Okay. Alpha, or what, alpha? Sorry. Wow, I just said whatever y'all said. This is second x squared, and it will put a square root symbol on my calculator. So you can type in 49, and it would kick out 7. So if you didn't know your square roots, got you. We should have our squares memorized up to 10, if not 12 or 13. Okay? I'm going to give you all like a hot second to fill out the rest of this paper. I need to know if you know all your square roots. Let's see how quickly we can do it. On your marks, get set, go. All right, here I'm going to zoom out. We're just going to do this like a drill really quickly. What is the square root of 36?
6.
What's the square root of 144?
12.
What's the square root of 4?
2.
9.
3.
25.
5.
16.
4.
64.
8.
Tight. All right, so we got our square roots. Now, we're not going to be computing really anything with our square roots. We come back to the idea of computing and simplifying in the 5th 6 weeks, and I will teach you all about that later. But we're going to be using this symbol today. From here on out, I'm not going to call it a square root. I'm going to call it a radical. What's it called?
Radical.
Tight. Awesome. Radical, dude. Okay. Meet me on this paper. Okay. This is as much notes as we're taking today. What we're doing is super simple. It only requires a half page of notes. Now, rational means fractional or fraction. So what we're dealing with today is exponents that are written as a fraction. Now, technically, all the exponents we've been using have been that because x to the 5th power can be x to the 5 over 1. But like these are going to be fractions that are like 1/2, 7/5, 8/13. Okay, they're going to be like fractions that are not whole numbers, okay? We need to be able to write these from what's called, that's not the word I meant to write down. Wow. What am I doing? Get yourself together, Miss Quickly. Rational exponent form. That's the one where there's a fraction exponent. And we need to be able to change it and rewrite it into what's called
A radical.
radical,
Exponent.
just radical form. Okay? Exponent, yes. So we're changing it from rational exponent form to radical form. We're doing nothing else. You don't have to compute anything. It's not really even simplifying, it's just rewriting them into either form. Because when you get to Algebra 2, there's going to be numbers and expressions that you use that are easier to compute in rational exponent form and others that are easier to compute in radical form. So we need to be able to go back and forth between these two forms. They're the same thing, just written in a different way.
You're scaring me.
You're fine.
I don't like cooking homework.
So here's the acronym that's going to help you do this rewriting. Literally all we're going to do is take the a to the m divided by n power and rewrite it into the nth root of a to the m. What are some things you notice about the letters and where they go?
The inside went outside.
The what?
The N went out.
The n went outside.
And the A and the M went together.
The m went inside as an exponent. Did the base change?
No.
No, and then this n, is it like in front of it or is it like small and in front of it?
Small.
I'm glad you noticed all those things because that's super important. The rule that we're going to be using to talk about this change between them is called T-bow. You're going to take the top number in the fraction and you're going to put it inside the radical as an exponent. Okay? Top goes inside. That's the TI part of T-bow. Top number in the fraction goes inside the radical. Top goes in.
Don't do that.
What do you guys think the BO stands for?
The bottom goes out.
The bottom number in the fraction goes outside the radical. This is called an index. You don't have to know that word, but I'm giving you extra information. So the bottom number goes outside, and it's little. It's like chilling on the edge of that radical. Okay, it's not in front of the radical. It's not multiplied by the radical. It's little. It's called its index. Chilling on the roof, chilling on the shoulder, however you want to think about it. It's small.
In the bathroom.
Or maybe not that one. Okay, top goes in, bottom goes out. The numerator goes behind, the denominator goes in front. Top goes in, bottom goes out. And that's all we're going to have to be able to do, my friends. We're just going to write it from one form to another today, back and forth, making sure we can get them from one form to another. You ready to see an example?
No, not yet.
Ah, okay, I'll wait. Oh, by the way, y'all look at this funny picture I have. So, T-bow. Does anyone know anybody in the world that's name is T-bow?
No. Devo?
Where's my football people at?
I know Devo, not T-bow.
There's a quarterback for, who did he play for?
T-bone?
Wait.
Honestly, I can't see. His logo's not showing up in him. But his name was Tim Tebow. Y'all ever remember about Tim Tebow?
I know T-bone.
Not T-bone, Tebow. Okay, this is Tim Tebow, and he got famous because he always used to like go in the end zones and pray. And you really can't see in this thing, but like, man, it's really bad.
It's really bad lighting.
It is. I wish I'd show you because there's a square root, a radical sign. Can you see it? He like makes a radical sign right here. No, you can't see it. It's funnier in person. Here, pass this from table to table. Okay, so Tim Tebow helps us remember that when we have the radical sign, we use the Tebow rule. Top goes in, bottom goes out. Okay. Yeah, pass it around from table to table. That way you can see Tim Tebow.
I want to see.
Yeah. Okay, while y'all are passing that around, here we go. We only have 4 problems. And before we get started, I need you to make a change to problem number 4. So problem number 4, I want you to mark out that negative sign. Problem number 4, just mark out the negative sign. I don't know why that's there. My bad. Mark out the negative sign on number 4. Did everyone mark out your negative sign?
Great. So they've never had
They might, but it's a different rule that you're not going to talk about till like second semester of Algebra 2 and or pre-cal, so we're not going to deal with it yet. Okay, now we want to write an equivalent expression for the following. We, on number 1, have a fractional exponent. So what form am I going to write it in? If it's already fractional, I'm going to write it in radical. Very good. Okay?
So you want to put the 3 inside as an exponent, and you will put that to the exponent of the x, and then put the
Yes.
4 on the outside.
Mickey's right. So I'm going to set this up for you. I know I need it in radical form, so here's my radical. Do the bases ever change?
No.
So that means the x goes inside. Okay, now I do top in, bottom out. The top number is what?
3.
And it goes inside the radical sign as an exponent. The bottom number is,
4.
so it goes on the outside, chilling on the little edge. It's not as big as the radical sign. It's little. And it's important that you write it that way. This is the fourth root of x to the third power. Fourth root of x to the third power.
I don't want to solve these.
That's it. There's nothing else. Fourth root of x to the third power. Top went in, bottom went out. Like, don't make it as hard as it can be. Top goes in, bottom goes out. Now, I will ask you to rewrite them the opposite way. If I give it to you like number 2, in this form, what's this form called?
Radical.
Radical form. What form do I want you to write it in? The fractional rational version. Very good. So it's like backwards, Tebow. So does the base ever change?
No,
So it's r. The top number was inside. What's the top number?
7.
The bottom number
5.
is outside. So this is r to the 7/5 power. The fifth root of r to the 7th power is the same as r to the 7/5 power. All we're doing is being able to rewrite them in the two opposite forms today. Chill? All right, the only way I can make it not chill is if I give you a question like number 3. What's wrong with number 3?
A lot is wrong with
Oh,
A lot is wrong. We have some invisible numbers going on here, right? So let's talk about our invisible numbers. Here we have this whole little graphic, this little box about our invisible numbers. What is the invisible coefficient? 1. Because any x is the same as saying 1x. The invisible coefficient.
it's also 1.
What did we learn about the invisible exponent?
It's always 1.
It's always 1. X is the same as x to the first power.
Oh, that's how you do it. Don't let
So, question. What do you think the invisible exponent is going to be? It's not. Question. Go back to what you knew before you came here today. What did you call this symbol before I told you it was called a radical? A what? A what root? What number is it going to be if it's a square root? It's a 2. The invisible root, the invisible index is a 2. Because the square root of x is a square root of x. If that was a 4, I'd be saying a fourth root of x. So the invisible one is a square root of x. Square is 2. Square root.
Is it y1/2?
To the 1/2. Okay? So if I write in my invisible numbers, I've got a 2 on the outside because it's a square root. And I've got a 1 on the inside because that's the invisible exponent. The bases never change. The top number was in. The bottom number was out. Yeah, still top in, bottom out. You just had to deal with the invisible numbers. The invisible root is 2 because square root, which makes sense. And the invisible exponent is still 1. Now, I've asked this every single time. For number 4, do the bases ever change?
No.
What's the base in number 4?
X, y.
X times y, okay? I don't change that when I'm writing it from rational form to radical form. So I'm going to set this up for myself with the radical
X, y.
and my whole base. Are those parentheses important?
Yeah. Because without
I told you earlier to get rid of the negative.
without parentheses, you'd only multiply times 2.
And then I do top in, bottom out. What's the top number?
2.
That goes on the inside. What's the bottom number? That goes on the outside. That's it. That's all you have to do. You have rewritten it into radical form.
Yay.
The parentheses are important, though, because if you don't have the parentheses, you've written an entirely different question.
For real.
For real.
What does the parentheses mean? Oh my
The parentheses means that the squared on the outside goes to both the x and the y, because it's a grouping, not just a single. That's fine. Put the number there. So, do I have any questions before I let you glue these into your spiral?
No.
I love my spiral.
Yikes. Take 3 seconds to glue these into your spiral really quickly, and then I want you to clear everything off your desk except for your notes. So any extra pieces of paper, you don't even need a calculator, you don't need a Chromebook. Put it all underneath your desk.
I don't even